All right, so here's the plan for today. We're gonna do a little warm-up program, a little warm-up problem, and then we're going to do some projectile motion, which is an application of quadratics and inequalities and all that stuff. And so we'll talk more about that. What you're supposed to be looking at right there is a wonderful YouTube video of a cannon shooting a cannonball, kind of a deal, and how the motion goes, and so normally you would have you would launch something, let's say from here, okay, and then it would go out and up, and then it would come back down, okay. So you have a horizontal component and a vertical component with it. The horizontal component, a lot of trig involved in that. We haven't gotten that far yet. So today we're just going to deal with the vertical motion of that, and we'll get to that momentarily. But first, I want to start with a warm-up problem. So, yesterday's formative, not the best effort that I've seen. Okay, you get it. It happens. Okay, we asked a lot of you. We asked you to, on your own, learn 3 sections. And then we went through some different ways of teaching the other 3 sections that were going on in there too. Okay? So I get it. Okay? But that doesn't mean really anything because it's formative. Okay? They weren't the best, but you know what? I'm fine with that. It's formative. That's where I want you to make mistakes. I don't want you to make mistakes next week, Wednesday. Because that's not formative. That's a one-shot deal next week, Wednesday. Don't forget that next week, Wednesday, you will have 7 homework assignments due. Okay? 6 out of the book and 1 worksheet. If you're not going to be here tomorrow, the worksheets are over in the purple carrier cart crate thing, whatever you want to call it, over there on the table. Okay? So let's learn from our mistakes that we had yesterday. Okay. Write the point-slope equation for a line through the point -2, 7 with a slope of 1/4. Okay. Now, throughout the course of your algebraic careers, you have learned 3 distinct forms of an equation, of a linear equation. Okay. Give me one of the 3 that you have learned. You can either give it to me by its name or by what it looks like. What does that look like? Do you know? Y equals mx plus b. This is not point-slope form, right? So I don't want my answer to look like y equals mx plus b. Yesterday, when I was correcting them, I was okay, or I was the nice grader. Okay? If you got the y equals mx plus b form of the point-slope form, so you had to use the point-slope form but just went too far with it, I gave you the credit for it. Okay? Mrs. Hill and Mr. Roth did not. Okay? I was the nice one. Okay? I was 2.5 instead of 97.5. Okay? All right? That will not happen on Wednesday. Okay? Wednesday's a whole different story. Script, another one. Standard form. Do you know what standard form looks like? And with standard form comes a couple of different conditions, right? No fractions, no decimals. A is positive, right? Okay? So we got all those 2 extra conditions to go along with it. Still not point-slope form, right? Does anybody remember point-slope form? Close. Very close. minus y sub 1 equals m times the quantity x minus x sub 1. Okay, that is point slope form. So, if I want the point slope form of the equation of the line through that point with that slope, it's going to be what? Y minus 7 equals 1/4 times the quantity x minus negative 2, which is x plus 2. Yep. And that, ladies and gentlemen, is it. That's all you got to do. Because that's the point slope form of that line. If I said give it to me in standard form, then there's more work for you to be done. If I said give it to me in slope intercept form, again, more work to be done. Okay? Okay? All right? Whew, I feel all warmed and loosed and ready to go. Okay? So, a projectile is launched vertically, or a projectile launched vertically can be modeled by the equation S equals negative 16t squared plus v sub 0 t plus s sub 0, where S is the height of the object at any given time t, v sub 0 is my initial velocity, how fast we launched it, and s sub 0 is the initial height at which we launched that object. Okay? As I said, today we're only launching stuff straight up. Okay? So we're only throwing a ball straight up in the air and it's going to come right back down, or we're launching a rocket, okay? Or maybe we're lighting off a firework, okay? Something like that. Okay, we're going straight up. We have no horizontal aspect to it yet. We're not ready for that yet. Okay? All right? So that's what our scenario is. And more than likely, through some kind of a science class, you saw the vertical motion equation before. Okay? So, stole this one out of your textbook. Okay? I can't remember. Actually, I can walk over here and remember. Page 64. Oh, nope, not a homework problem. But that's okay. I'm okay with it. Okay. So, a projectile is launched straight up from ground level with an initial velocity of 272 feet per second. Now, there's a lot of things that are told to me just in that one single solitary sentence. First off, what is told to me is because that we are dealing with feet in feet per second, that my height, S, is going to be in feet. Okay? So if I'm not in feet throughout the rest of the problem, I've got to convert it into feet in order to use it. Okay? That gets told to me. Second thing that gets told to me is this whole 272 feet per second. What is that? My what? Even more than my velocity. My initial velocity, which is v sub 0. Okay? V sub 0 is my initial velocity. One more important piece of information.
The starting height, because it says you're starting from ground level.
So my starting height is 0. Yep. So this is my S sub 0, and that is going to be equal to 0. Okay? So question A says, write an equation that models this situation. Well, the equation would be S, my height, is equal to negative 16 t squared plus what? 272t plus what? 0. Okay? Now, you don't have to write that plus 0 part. Okay? We don't write plus 0 in math. We don't write times 1 in math. Okay? Right? If you do, hey, more power to you. You're just remembering that your initial height is 0. Okay? But there is our equation that models said situation. Okay? When will the height of the object be 960 feet above the ground? Okay. So how would I figure out when that object is going to be 960 feet above the ground? Plug in 960 for S and solve for T. Make it happen. Okay? We're going to plug in 960 for S. So we're going to have 960 equals negative 16 t squared plus 272t. And you're going to solve that for t for me. Go for it. Now, you will hear from me multiple times that there is more than one way to skin a cat. It's an old saying. Okay? There's more than one way to do a problem. Okay? So the way that I'm doing it is not necessarily the way that you did it. Okay? But it probably is. This guy up here, am going to add 16t squared to both sides. At the same time, this guy up here, is going to subtract 272t from both sides. The reason that I am doing that, my justification is I want a positive squared term. Okay? That's what I want. And what I want, I get. Okay? You know it's true. Okay? Alright? Then, luckily for us, 272 is divisible by 16. Okay? Also, luckily for us, 960 is divisible by 16. So I can divide all of these terms by 16. Which then gives me t squared minus 17t plus 60 equals 0. What's up? Same thing. You can divide everywhere by the 16, factor it out, and then divide it by the 16. Either way. Okay? Again, doing the same thing. Yep. Okay? Luckily for us then, this is a factorable quadratic, and it factors to be t minus 5 and t minus 12. Okay? Negative 5 times negative 12 is positive 60. Negative 5 plus negative 12 is negative 16. Okay? Then, that tells us that t minus 5 is equal to 0, so t would be equal to 5. T minus 12 then would equal 0, so t would be equal to 12. Does that logically make sense? To have two time values where we are at 960 degrees. Why does that logically make sense? Go ahead. You've answered 2, 3 in a row.
Parabola, so it's going to go up and down.
But really, it's not a parabola because it's going straight up and straight down, right? Okay.
There are 2 times where it will reach that height.
So it'll reach at 5 seconds on the way up. Then it goes up still, gravity takes hold, and then 12 seconds on the way Yeah, yep, exactly. Okay. So our object is at 60 feet on the upside at t equals 5 seconds, and on the downward at t equals 12 seconds. Okay, love it. So, give you a couple of minutes here to answer these two questions. I like to draw myself a little picture. So it goes up and down, and then there's this whole 960 feet line. Okay? So we know that on the way up, this is at t equals 5, and on the way down, this is at t equals 12. Okay? So it must reach its apex then, right up there, at what? When would it be at its peak, at its highest point? Great thought-provoking question, Linsmeyer. Glad you asked. Anybody know?
8.5 seconds.
How'd you come up with 8.5 seconds?
The difference between 5 and 12 divided by 2 to one of the points.
Okay. Do we agree with 8.5 seconds? Okay. Because it's got to go up, and it's got to come back down, right? So if it's at any point in time when it's the same height, that's going to be symmetrical. The first half of it is going up, right? And then the second half is it coming down. Those halves are equal. Okay? So up here, it's at its peak at t equals 8.5 seconds. Which means down here, it's at t equals 0, and it comes back down and it hits the ground when? At 17 seconds. Okay. Now, again, that was all using the symmetry. Okay? We could have also said, well, it took 5 seconds for it to get up to 960 feet, right? Which means it's going to take 5 seconds for it to get down from 960 feet. Okay? So 5 added to 12 gets me that 17. Okay? Right? And then halfway between and halfway between and halfway between. Right? Okay? So the two questions are, when will the height of the object be at least 960 feet? So that means we want to be above 960 feet. So that would be from 5 seconds to 12 seconds. In interval notation, that would be 5 to 12. In inequality, words, interval, inequality. Whichever way you want to answer. When will the height of the object be at most 960 feet? So this means below 960 feet, right? Right? So when will it be below 960 feet? from 0 seconds to 5 seconds, and 12 to 17 seconds. Or that would be oops. Whoa. That should be a bracket. Whoa. That should be orange. Why is it going to red all the time? Yeah, buddy. Yeah, buddy. All right. So, tomorrow we will have a couple of warm-ups and some review. Monday, Tuesday, we're going to take the EMPT. And then Wednesday, we're going to take your test. And all of your homework is due on test day, Wednesday. Okay? Thanks for playing along.